Hello guys, welcome to my YouTube channel, and today I'm going to show you how I set up this Matek F405 CTR flight controller with an Arduplane firmware, so for fixed swing use. So okay, let's get started. Start by opening this flight controller from its packaging. So here you will see this Matek F405 all-in-one integrated board. You have the power module or the voltage and current sensor here. The OSD is integrated in the system. We have SD slot for logging information from your flight controller. You have your BEC as well as your pads for the UART or the serial ports and your motor ports. So this Matek F405 CTR board is popular on racing quad setups, but recently this board has been used for fixed wing. Paired with this GPS module, you will be able to fly your fixed wing with GPS assist using the iNav firmware. Originally, I intended to use this with iNav, but of course with the recent release of the Arduplane for CBOS boards like your F4 board here, I opted to use the Arduplane firmware. Why Arduplane firmware for this Matek board? Mainly because this Arduplane firmware is a matured ecosystem. It has better flight modes, full autonomous mission flights, capable of advanced camera controls, and so on, making this iNav firmware just a portion of the group of stuff that you can do with the Arduplane. And right now, since this Arduplane is not compatible with this board, we're taking advantage of the Ardupilot ecosystem, which was popular on APM boards or Ardupilot mega boards, as well as on Pixoc boards. With regards to wiring setup for the Matek F405 on our iNav, I downloaded this manual from the Matek Sys website, and here you can see how the servos and ESC are connected to the Matek F405 CTR board. Servos are connected to S2 and S3, and the ESC is connected to S1. So that is for the flying wing configuration. Comparing it with the Ardupilot setup for Matek F405, you notice that you need to swap S1 and S3 connections. So meaning your servo 2 should still be on servo 2 or S2 port, and your other servo should be connected to S1 instead of having it on S3. And your ESC here will now be connected to the motor output 3 or S3. So putting it side by side, you notice the difference on the wiring setup. So once you decided to move or to migrate from iNav to Ardupilot, you need to change your wiring setup and swap S3 and S1 components so you can have it working properly on Arduplane firmware. For the GPS, this is a Furious FPV mini GPS module without compass. This is a Neo 6M type, if I'm not mistaken. An iNav setup, to connect the GPS to serial ports or UR ports 4, TX4 and RX4. TX goes to RX. If you notice here, TX goes to RX, and RX of the GPS goes to the TX. On Ardupilot setup, you can still use this Furious FPV GPS, but you need to take note of the UART numbering on the Matek F405 board is not the same as the numbering of the serial ports on the Ardupilot firmware. So I have here a list for the serial ports and UR ports assignment. On Ardupilot or Arduplane 3.9 to 3.10 dev firmware, serial number 1 or serial port 1 is corresponding to Matek UR pin number 3. So this is TX3 and RX 3. So this is your serial port 1 on the Ardupilot. Serial port 2 is corresponding to the UART number 4 or TXR RX4. Serial 3 is for UART 1, serial 4 is for UART 5, and serial 5 is corresponding to for UART number 6. So you have to take note of those serial number assignments for Ardupilot use. Okay, now we go on flashing this Ardupilot firmware on the Matek F405 board. But before we proceed, you may need some softwares. Of course, you need the Beta Flight Configurator or a Clean Flight Configurator tool or an iNav Configurator tool. Anything that you can use to flash your firmware to your Matek board. You may also want to download the Impulse RC driver fixer, just in case your computer cannot detect your Matek board on the FU mode. And you may also want to have the Zadig driver fixer tool. So it's almost the same as the Impulse RC driver fixer. Those will come handy just in case you cannot flash or go to the DFU mode on your Matek board. Okay, so let's press this button and plug your cable. So on DFU mode, you'll notice that it will have this red LED lit and also this LED here lit, steady LEDs. And on your Beta Flight, on this part, you'll see that it says that your flight controller is now on DFU mode. Okay, so we go to the firmware flasher tab and let's load the local firmware that we've downloaded a while ago. That will be Arduplane with BL hex. Okay, so it will take quite a while to load the firmware, and you will be waiting for this flash firmware button to be enabled before we can start flashing this firmware to your Matek F405. So while waiting, we download the latest or the beta or the stable firmware, or use the daily builds that we have for the Ardupilot firmware. And right here on this directory, we have the 2018-07, or this is the July 2018 builds. Let's select the latest daily build. This is July 30, 2018. So you will be directed to this link, and let's select the Matek F405. And now you'll see here the Arduplane.hex firmware and the Arduplane with BL.hex firmware. So this is the one that you will need to download, because for first time flashing, the Matek F405 board will require the bootloader for Ardupilot firmware. So let's download this one, save link. Okay, save it. Once you've downloaded the firmware, you go back to the Beta Flight Configurator and open or click the firmware flasher tab, and let's load the local firmware. Okay, select the firmware that you've just downloaded. That will be the Arduplane BL hex. Okay, so If you notice, this flash firmware button is now enabled, so just click on it and let's wait for the beta flight configuration tool to do its job. Erase the existing firmware and flash the Ardupilot firmware on this Matek F405 board. So now we unplug the Matek F405 board, and on your computer you will need another software called the Mission Planner or any other ground control station software that is compatible with the Ardupilot, but I would highly recommend that you download the Mission Planner because this ground control station software is very comprehensive and it will help you out on the setting up of your Ardupilot firmware on this Matek board. So let's look for the Mission Planner. Go to the Mission Planner website. Basically, this is under the Ardupilot website, and go out and download this software. So on my computer I have already downloaded it, so I will just load the Mission Planner software. This is the main interface of the Mission Planner once you loaded the software. Let's zoom it out a bit. Okay, so you have the flight data screen, the flight plan or the mission planning screen, initial setup screen, config tuning screen, simulation tool, the terminal, but this is not functional on the latest Arduplane firmwares, so this is for the old APM models. Help and the donate tab, and what you're going to do here is to connect this Matek board to your software. So to do that, you need to change this communication port serial port number corresponding to your Matek F405 board. So let's plug your Matek board to your computer. So notice the blinking LEDs here, and on this portion of your Mission Planner software, okay, so you need to change the serial port number according to your flight controller. So this is COM85 for my case, and make sure to set the baud rate or the speed of connection to 115/200. Okay, so take note of that, 115/200 baud rate, and hit on connect. Okay.
Mode change to
And there it
RTL.
is.
Bad compass health.
Okay, so if this is your arrow on your flight controller, this means that you'll be facing this flight controller forward. So if you pitch it down, push it up, left, right, roll, and yaw, you'll notice that the heads-up display is updating. Okay, so once you've done that, congratulations, you have successfully loaded the Arduplane firmware on your Matek F405. And to confirm what version you're using on your Ardupilot firmware, you can click on this messages tab and see that this is Arduplane 3.10.0 dev firmware, and this will be the firmware that you'll be using on this F405. Okay, before we go on setting up this firmware, you need to work on the hardware first. Connect the servos, connect the speed controllers, the external BECs, your VTX, your camera, your power supply here through XT60 connection or DINS plug connection, whatever or whichever you want to use, and of course your micro SD card for logging. So on my setup, I have already done that on my fixed wing, which is the Reptile S800. So So this is my Reptile S800, and this is the Matek F405. GPS is here connected to my I've chosen serial port or UART number 3 on this Matek F405. Take note that UART number 3 is corresponding to serial 1 on the Ardupilot. That's Ardupilot firmware or setup. Okay, so
No IO thread part feed.
servos are now soldered here. Are for this is on S1 and the other one is on S2. Okay, so the ESC is connected on S3. So this is your motor out number 3. Okay, you also need to connect your receiver on the S-bus pin and so on. And of course, once you've done with the hardware component, you're now ready to calibrate. So to do that, all you need to do is plug your USB cable on your flight controller. So it's now booting up. One thing to remember when using the Ardupilot firmware, during the boot up sequence, you have to place your flight controller on a stable mounting, minimize the movement on the flight controller or the frame itself to help it calibrate the gyros and axles correctly. Okay, so once you've done that, you go back to the mission planner and click on connect. Oops, if it feels unconnecting, maybe you need to change the or update the serial port number here and hit on connect.
U block 1HW000800000 southwest. From core 3.01 107,888. Mode changed to RDL. Bad GPS signal health.
Okay, so it's now connected. Flight data screen. So if you move the plane, the heads-up display also updates or moves. Now we go to the initial setup. This is where you need to perform your calibrations on the sensors, the power module, and so on your Ardupilot firmware. So you can use the wizard, but I'd rather use the mandatory hardware and optional hardware tabs for manual calibration. So on the mandatory hardware, this is a step-by-step sequence. If you notice here, you need to start with the axle calibration, then compass, radio calibration, then you check the servo outputs, ESC calibration, setting up the flight modes, and the failsafe for extra security or protection on your Arduplane setup. But you may notice that this compass tab won't be used on the Arduplane firmware or the Arduplane setup because we don't have a compass on board on the GPS module. This is a GPS only module and the flight controller doesn't have a compass. Anyway, compass units are not necessary for Arduplane, but for multi-rotor setups you have to make sure that your GPS module has an integrated compass on board, or your flight controller itself should have a compass module on board. Okay. So we go first to the axle calibration. So this will calibrate the accelerometer on your plane or Arduplane. Okay, so this is a 6-point axis calibration. The first one, calibrate accelerometer. So click on that.
Place vehicle level and press any
It
key.
asks for your plane to be leveled and press any key.
Place vehicle on its left side and press any
Okay, so
key.
I have placed the plane here. Now I go tilt this plane on its left side. Okay, so just follow the instructions.
Place vehicle on its right side and
Press the key whenever it's ready.
Place vehicle nose down.
Nose down.
Place vehicle
Nose up.
and press any key. Place vehicle on its back and press any key.
Okay, and it's back. Sorry. It doesn't need to be strict on that.
Calibration success.
The plane down here on the table. You can perform the second level of calibrating the accelerometer. So this is the second button here. Just click it. This button. Wait for it to finish. So it's now indicating that the calibration has completed. Okay, proceeding to the radio calibration component. So here we're skipping the compass because you don't need the compass on this Arduplane setup, and besides, you don't have compass on board. Okay, for a multi-rotor setup, compass is critical, but for a plane, this is an optional component. Okay, so for the radio calibration, okay, so you will be directed on this page, but before you go on proceeding with the calibration, you need to power or provide power to your receiver, okay, through this XT60 port. Zoom it out a bit. Okay, so at this moment, the flight controller, which is powered by through the USB cable, is not supplying power to the receiver. So in that case, we need to add our LiPo. So if I take my controller here, you can notice the response of this flight controller. Okay, so
Mode change.
just make sure that you have assigned
Mode change to manual. Mode change
at
to
least
stay.
6 channels on your
20.1.
mixer on your radio. So for this case, I have set up to 16 channels, although I'm not sure if I'm going to use all of them, but as a basic setup on the Arduplane firmware, you need at least six channels to use. Then once you've connected your radio, you have perform binding for the receiver and the transmitter, and you have to make sure that the information here is updated once you, or every time you change the stick position. And then you can proceed on performing the calibration. Click on the calibrate radio button, and it says that you have to ensure that the transmitter is on, receiver is powered and connected. Ensure that the motor does not have power or the propeller. So we have to remove the propeller from your motor, just to make sure that no accidents shall happen during this calibration procedure. Okay, so click on the OK button, zoom it out. So at this point, we're trying to detect the limits of your radio sticks by performing physical movement of the switches. Notice the red marks on the mission planner moving as you also move
Mode change
the
to
switches
COUN.
on your radio corresponding to the channels.
Mode change to FEW. Mode change to manual. Mode change to stay alive.
Okay, so just proceed on the calibration part, and also
Receiver
try
still connected.
turning off the radio.
Telemetry lost. Telemetry recovered.
Okay, so I've turned off the radio
Throttle
and
fail safe on.
turn it on
Welcome
again.
to OpenTX.
Fail safe. Short
Switch
event on.
warning.
Type equals 1/reason equals
Okay,
3.
so once you're done, you can now click on this
Long event
button,
off. Reason equals 3.
and it will prompt you that the calibration is done with the following limits on your light controller set. Okay. Next, we're going to check the servo outputs if these control surfaces are moving accordingly. On the servo tab or servo output tab, you can notice here or check here the assignment for the servo outputs. For channel 1, this is assigned to aileron. Channel 2 is this assigned for elevator. Channel 3 is rudder. Throttle. Channel 4 is rudder, and the rest are disabled. Actually, we can also disable the rudder because you don't have anything connected physically on the S4 pin on the Matek board, so you only have these three. Okay, so since you're setting up an L1 type fixed wing, which is a flying wing, you need to select the output accordingly and look for the L1 left or right parameter. So for channel 1, you'll use L1 right, and for channel 2, you'll use L1 left. Okay, channel 3 is still throttle. Click on the servo output again to update. So okay, so see if the L1s are now moving accordingly. Okay, so
Telemetry lost.
if you notice, if I pull the stick backwards, the control surfaces are moving at the opposite direction. So moving it backward, it's still the same. Inputting aileron command, aileron left makes the control surfaces, both of them go upward. Aileron right makes the control surfaces go downward. So there's something wrong with our setup, and we
Telemetry
need
recovered.
to update it first. Okay. So this is fixed by reversing the output. So we can try reversing channel 1 first. Okay, so click on servo output again, then go back to your setup, to your plane, and see if it's right. So now if I pull this stick back,
Telemetry lost.
elevator or the L1 is now reacting right. Push it, so it's right. Okay, now it's correct. So you're done with the calibration of
Telemetry
your
recovered.
servos. Okay. For the easy calibration, we will do it later on when we plug the throttle cable to your receiver or set it through pass-through mode. Then flight modes. I have selected these flight modes for my basic requirement. For the flight modes, I have selected these following flight modes, but you can change this if you desire to use another or different flight modes, whichever is available on this list. So we have stabilize, firmware A, auto mode, auto tune. This is for tuning part, RTL and manual. Just make sure that you click on save once you're done with the flight modes. Then for the failsafe, okay. So this is for the radio failsafe and battery failsafe. For the Arduplane setups, a battery failsafe is not recommended to use because it will trigger return to launch even if you're on low power, so you don't want that. On multirotors, this is helpful, but on plane this should be optional. But what is needed here is to set up a failsafe for the radio. So if you are disconnected on your radio, it should trigger return to launch command, and this is achieved by detecting a low PWM value on failsafe. So At the moment, channel 3 here is 982 PWM on its lowest position. On its highest position, it is 2006. So 982 and 2006. Okay. So if I turn off my radio,
Receiver still connected.
okay,
Throttle fail safe on.
it should trigger
Fail-safe.
a failsafe
Long event
command.
on. Type equals to flash reset equals 3.
Depending on your radio, you need to set up a failsafe command here. Okay, so on my radio, I set it to no pulses, meaning if I turn off or disconnect this radio from my flight controller or from my receiver, it should
Receiver still connected.
it should indicate a no pause signal on
Throttle
the
fail safe on.
receiver. So it happens, it will engage RTL.
Long event on. Type equals to flash reset
Normally
equals 3.
you set a low PWM value here, which is lower, a bit lower than the lowest value on the throttle signal. With throttle set to minimum, this is 982. Your failsafe value should be a bit lower. This is set to 950. Okay, so once you're done, click on the failsafe. Okay, so this will update the values. And for the optional hardware, we can set up the radio telemetry radio modules later on. The battery monitor. For the battery monitor, you need to configure it later on the parameter list, as well for the OSD and so on. So you will be conducting or performing this calibration on the configuration tab. Okay, so on the config tab, you can perform basic tuning and advanced tuning, or see the full parameter tree or list. So here we have the full parameter list. We'll try to set up the GPS first. So if you recall, we installed the GPS on UR3, and UR3 is corresponding to serial port 1. So you need to search for the serial port 1. You can use the search toolbox here, serial 1, enter. Okay, so we have to change the value here for the serial 1 protocol to 5. Why 5? Because 5 is dedicated for GPS use, and set the baud rate according to the specifications of your GPS module. For U-blocks, New6M or for previous GPS module, it is set to 115-200. So I select 115-200, and this will be 115. If your GPS requires a lower baud rate like 38-400, so you need to type 38 here. Anyway, just check your specification sheets. So in the setup, I use 115. Click on the right parameters to save the information to your flight controller. Okay. So next, we need to set up the OSD. Search for OSD. Searching for OSD will reveal to you this list that you can configure. So OSD type. I'll give you the link for the OSD parameter settings. Basically, how you will be configuring the OSD without the need for an additional external software. So everything will be native on the Ardupilot firmware. Okay. So what we're going to do right now is to set up the battery voltage and current monitor settings. So let's look for the BAT keyword. So everything that has a BAT keyword will be displayed on the parameter list. So for the BAT ampere volt, I set 30.7. So this is a value that will give me a proper calibration. You need to perform your own calibration later on, but for now we can use my values 30.7 here. This is out of focus, and that was 30.7. Okay, this one, bat current pin for Matek boards, Matek F405 boards, set the bat current pin to 14, and bat volt pin to 15. Okay, so take note of those numbers, 14 and 15. So change the values to 14 and 15 accordingly, then click on the right parameters. Okay, so right parameters, and for the battery monitor setting, this one, the value for bat monitor should be 4. That will be for voltage and current configuration. So set it to 4, then click on right parameters again, then you're done. Okay, so going back to the flight data screen, you will see here GPS signal if you have satellite fixed, and the battery voltage and current. So at the moment there's no LiPo connected, so this is 0, but if I connect a LiPo to the XT60, okay, so the battery here, the battery voltage reading here is now updated, as well as the current reading. To check if you have this GPS already working, all you need to do is click on the status tab and still down, look for the GPS status parameter. So if it is indicating a 1 here, then you have successfully interfaced your GPS module. It should the GPS HDOP value should be lowered down to 2.2 or less once you are outside the building or outside your house, able to connect to the satellites. Satellite count will give you the number of satellites locked to your GPS module, or locked on your GPS module. You need the GPS to perform the return to launch, the cruise mode, as well as in the fly-by-wire beam mode. But if you don't have the GPS satellite lock, you cannot arm your plane or arm your Arduplane setup. Okay. So I guess that's all for the moment. Once you completed the configuration, the parameter setting, the failsafe setting here, you can proceed on arming your plane. Just make sure that you're outside so you can have access to GPS satellites. Make sure you have the plane level. Just look at this HUD. But of course, you cannot fly with this USB cable connected. You have to disconnect it. And if you want a wireless communication between the plane and your ground control station, you need to add a telemetry module on your setup. Connect it to one of the UART ports and set it up in the mission planner. And again, okay, I guess that's it for today. Thank you again for watching, and see you soon.